Here's a background on the pH scale. So the pH of a substance can actually be calculated if you take negative log of the hydrogen ion concentration of that substance. Now, whatever this equals to is going to be put on a scale. If the pH is 7, that's like a neutral position, okay? So we're talking about pure water. But if you get lower and lower on the scale, you're going to talk about more acidic things. And on the other end of the spectrum, if you go higher and higher on the scale, you're talking about more alkaline or basic things. So here are the types of questions that you could see. A and B are fairly general, and then C is kind of like a little bit weird. So let's just tackle the easier ones first. Find the pH. Okay, so already they're telling you this is your unknown. If the hydrogen ion concentration is this, so they've told you the H. So I put it into an equation. I'm looking for my unknown, which is my pH. It's equal to negative log of the hydrogen ion concentration. So, since pH is already isolated on one side, we can just put this into the calculator and figure out what it equals to. I got about 4.2. And when we're talking about pH, 4.2 doesn't have a unit beside it. So you're just going to say, therefore, the pH is 4.2. And remember, these are application word problems, so you need a therefore statement at the end. Now, if you're talking about B, they've given us the pH of the seawater already. So our unknown this time is the hydrogen ion concentration. That means the 8.5 is going to go here instead, and H is going to be our unknown. Okay, so the thing is, your goal is to get H by itself, and I have seen so many people try to divide a negative log out and bring it to the other side so that H could be isolated. You cannot do that, okay? Try it on your calculator. It's going to say that there's an error. It's just going to be confused. So let's show you this on a separate slide. First of all, I want log by itself on one side. I don't like this negative, okay? So let's bring it to the other side by dividing both sides by -1. When I divide both sides by -1, the negative ends up on this side, so I get that log by itself. The reason why I want log by itself is now I can change it to exponential form and it'll isolate this H. So exponential form goes like this. The base of 10, right? There's an invisible 10 here. 10 to the power of your exponent is equal to your answer. So here we go. 10 to the power of the -8.5 is equal to that hydrogen ion concentration. And when I put this into my calculator, I get this really big number. Or I guess in this case, it's a really small number. Okay, so therefore the hydrogen ion concentration is 3.16 times 10 to the -9 moles per liter. All right, those are fairly easy questions. C is going to be a little bit more difficult, okay, because they've actually given us the pH of two things, and they want us to compare them. So how much stronger is this pH to this pH? So what I'm going to do is I'm just going to show you with the exact same equation, the pH is calculated by subtracting the stronger one minus the less strong one. Okay, so this one is more acidic and this one is less acidic. So we're going to take this minus this is equal to negative log of the H, okay, the hydrogen ion concentrations. Because we're comparing two different substances, I put them on top of each other, but your goal is not to figure out one individually. You're actually trying to figure out this entire unknown. All right, so let's do that on a separate slide as well. Subtract these two guys first. Okay, so you get something like this. Now what you're going to do is get rid of this negative, bring it to the other side by dividing both sides by a -1. So this becomes a positive 1.9 and this becomes a positive log. Okay, so this is perfect. I wanted log by itself. Now I'm going to do the same thing I just did. Make sure that you put this into exponential form. 10 to the power of 1.9 is equal to your unknown. Okay, so the answer is 79 when I put this into the calculator. That's it. I don't want to find H1, I don't want to find H2, I want to find them both together as a comparison. So therefore, it is 79 times stronger than the other acid. Okay, the next video is going to be on the Richter scale.